Now we'll look at how the inner ear functions. First, we'll look at hearing. The stapes is attached to the cochlea. And the place it's attached at is called the oval window. So this is the cochlea. And the cochlea is fluid filled and the neuronal receptors here are called hair cells. Essentially what happens is when the stapes moves on the entrance to the inner ear, it causes a wave in the gel. And we call the fluid a gel because it is fairly viscous. So it causes a wave in the gel. Different frequencies of waves, which we would talk about as sound, cause different hair cells to fire. Action potentials, I'm going to write APs down the vestibulocochlear nerve. That's all one word. I'm just running out of room here. That's cranial nerve number 8. And that is how you hear. Boy, did I make that a summary or what? So I'll use a black pen right here. It's the oval window. It's a thin membrane that the stapes attaches to this otherwise bony structure. And then right here, this is the round window. And it allows the excess pressure to be released through a thin membrane. So when the oval window pushes in, the round window pushes out. Near the beginning of the snail, that's what cochlea means, a snail, near the beginning are receptors for the higher pitch sounds. And then deeper within are the receptors for lower pitch sounds. So if someone subjects themselves to very loud music over time, the hair cells can be permanently damaged in the cochlea, and usually the first to go are the ones nearest the entrance. So I'm going to use green down here. We're going to move to the bottom. So hearing loss in the inner ear can be caused by loud sounds that permanently knock down hair cells in the cochlea. Okay, back up to the top. Let's look at the vestibule and the semicircular canals. The semicircular canals have canals that are filled with fluid, and they go in each of the 3 planes, so that when you nod your head forward or tilt it to the side or spin it around in a circle, each of these three planes works together to know how your head is moving and give you your sense of balance. So they're called the semicircular because of their shape. So they also contain fluid. The fluid inside of them, though, instead of responding to the waves that are coming in from the stapes, it responds to the movements of the head, or I should say it moves with, sorry. With movements of the head, and fires action potentials down the vestibulocochlear nerve. So even if someone was born with a cochlea that didn't work at all, so they were deaf, they would still have a sense of balance because the action potentials here are fired due to the movement of the head, not due to sound waves. So they fire action potentials down the vestibulocochlear nerve, which is cranial nerve pair number 8. And so there are little stones in the ear here normally move freely, but if they stop moving freely, then they no longer will report where your head is in space and you can have vertigo. So sometimes people have stones in their ears and they can get vertigo, which is a sense of dizziness or spinning. And sometimes they'll treat that with ultrasound, ultrasound aimed at the semicircular canals that can break up those stones that have stopped moving. Another interesting tidbit here is that alcohol changes the viscosity, and so the fluid will flow too much in some areas and not enough in other areas, and confuses the signals that are interpreted by the brain, and that is what they call the spins, because of the low density of alcohol as it diffuses into the semicircular canals. And then one last detail I would like to mention on the semicircular canals is that, or actually on the vestibulocochlear nerve, which we'll put that in yellow. So here's the nerve. It takes action potentials from the cochlea that are sending information about what you hear, and it takes action potentials from the semicircular canal, which carries information about where your head is in space, and takes it to the temporal lobe for hearing processing. And let's go ahead and, I guess, put this over here as we're running out of room. The vestibulocochlear nerve can be damaged either temporarily or, unfortunately, permanently by certain antibiotics. And this phenomenon is particularly well established with aminoglycosides. And as nurses are monitoring a patient that's taking aminoglycoside antibiotics, one of the side effects that they should be on the lookout for is either hearing loss or maybe dizziness that's resulting from the medication.